Good morning to everyone. I am Dr. Sumi MS. The name of the course is C Programming and Data Structures, and today's topic is trees from Unit 4 Nonlinear Data Structures. On completion, the students will be able to define what a tree is, explain the basic terminologies in a tree data structure, and also discuss the properties of a tree. Trees. A tree is a nonlinear and hierarchical data structure consisting of a collection of nodes such that each node of a tree stores a value and a list of references to other nodes, that is child nodes. So here node A is considered to be as the root node, and it has two child nodes, node B and node C. And node B is having two child nodes, node D and node E, and node C's child nodes are node F and node G. Here node D and node E are sibling nodes, and node F and node G are sibling nodes. All node E, node D, node F and node G are also called as the leaf nodes. And A and B are the ancestors of node E. Similarly, A and C are the ancestors of node F or G. Basic terminologies in tree data structure. Certain terminologies are important while traversing a tree. Parent node. The node which is a predecessor of any node is called its parent node. So here for node B, A is the parent node, and for node F we can still C is the parent node. Child node. The node which is the immediate successor of a node is called the child node of that node. Node B is the child node of node A, and node F and G are the child nodes of node C. Node D and E are the child nodes of node B. Root node. The topmost node of a tree, or the node that does not have any parent node, is called a root node. So in this case, node A is the root node which doesn't have any parent node, and it is the topmost node of the tree. A non-empty tree must contain exactly one root node and exactly one path from the root node to all other nodes of the tree. Leaf node or external node. The nodes which do not have any further child node is called as the leaf nodes. So here D, E, F and G are leaf nodes. Ancestor of a node. Any predecessor nodes on the path of the node towards the root is called as the ancestor node. Descendant. Any successor node on the path of a node towards the leaf node is called as the successor. So here for node A, B is the successor, and similarly for node F, C is the ancestor. Sibling. Children of the same parent node are called siblings. F and G are siblings. Similarly, D and E are siblings, and B and C are siblings. Level of a node. The count of nodes on the path from the root node to that node, that is said to be as the level of a node. So here the root node has a level 0, whereas node B is at level 1. Internal node. A node with at least one child is called internal node. Neighbor of a node. Parent or child nodes of any node are the neighbors of that node, and for node B, A and D and E are the neighbor nodes, and for node C, F, G and A are the neighbor nodes. Subtree. Any node of the tree along with its descendant is said to be as a subtree. So here we have BDE as a subtree and CFG as a subtree. Properties. Properties of a tree. Number of edges. An edge can be defined as the connection between two nodes. If there are n nodes in a tree, then there would be n minus 1 edges, and here since there are 7 nodes, there are 6 edges. There is only one path from the node to any other node of the tree. Depth of the tree. The depth of a node. The depth of a node is defined as the length of the path from root to that node. So each edge adds 1 unit of length to that path. So it can also be defined as the number of edges in the path from the root of the tree to that node. So here node B has a depth of 1 unit. Height of a node. The height of a node can be defined as the length of the longest path from the node to a leaf node of the tree. Similarly, height of a tree is the length of the longest path from the root of the tree towards the leaf of the tree. Degree of a node. The total count of subtrees that are attached to a particular node is called as the degree of that node. Leaf nodes doesn't have any subtrees, and hence the leaf node's degree will always be 0. And the degree of a tree is the maximum degree of a node among all the nodes in the tree. So syntax for creating a node. Here the struct keyword is being used. Struct, name of the node. Following that, variables are declared. There is an integer data and 2 pointers which are declared using the struct keyword. Quiz questions on trees. Write down the syntax for creating nodes in a tree. Determine the number of edges and degree of a tree which is given in the diagram with n equal to 7 nodes. Thank you.